Let's look at the solution of modern maths bites. Boxes numbered 1, 2, 3, 4, 5 are kept in a row, each of which are to be filled with one ball, either a red one or a blue one. No two adjacent boxes can be filled with blue balls. Then how many different arrangements are possible given that all balls of the same color are exactly in every respect? Okay. So basically, let's say we have to make cases of how many blue balls are there. So no blue balls. We would have one case, all boxes having red, 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 full. Then one blue ball. It can come in any of the 5 boxes. So 5C1 or 5 cases. 2 blue balls. You'd have to see where all can we do. 5C2 minus 4 cases where 1 and 2, 2 and 3, 3 and 4, 4 and 5. These 4 cases you have to remove from that. You would get 6 cases and 3 blue balls. There is just one case where this can work. Box number 1, box number 3, box number 5. One case. Altogether 1 plus 5 plus 6 plus 1 should give me 13. Answer is option C, 13. Next, if in a certain year the month of January had exactly 4 Wednesdays and 4 Sundays, then January 1 of that year was a. Okay. Now January has a total of 31 days. January has a total of 31 days. So can you see day 1, day 2, day 3, day 4, day 5, day 6, day 7. After every cycle of 7 days, days would repeat. Monday, Tuesday, Wednesday, this would repeat. So given that it has 31 days, you would have one cycle like this of 7 days. You would have another cycle. You would have another cycle ending on 14th, ending on 21st, and another cycle ending on 28th. But then there are going to be 3 days which are going to come 5 times. There are 3 days which are going to come 5 times. And there are 4 days which are going to come 4 times. Now the question tells me we had exactly 4 Wednesdays and exactly 4 Sundays. So the 3 consecutive days which have 5, which are coming 5 times. The 3 consecutive days which are coming 5 times. Let's just see. We have these days available: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. This is coming 4 times. This is coming 4 times. We need a group of 3 consecutive days which are coming 5 times. Can it be Monday, Tuesday, and something? No, not possible here. Not possible here. The only 3-day period that is possible is Thursday, Friday, Saturday. We'll have 5 days here, 5 days here, 5 days here. By extension, Monday will have 4 days, Tuesday will have 4 days. So this 1, 2, 3, 4, 5, 6, 7. This would start off at Thursday, then go to Friday, then go to Saturday, then Sunday, and all the way up till Wednesday here. The question was asking me what was the 1st of January of that year. Answer has to be option D, Thursday. There are 3 roads from A to B, and from B to C there are 4 roads and 3 direct roads from A to D. And from C to D there is only 1 road. How many combinations of roads are there from A to D? Okay, A to B to C to D. A to B there are 3 roads, B to C there are 4 roads, A to D there are 3 roads, and C to D there is 1 road. So how many combinations of roads from A to D? I can either go this path, A, B, C, D, or I can go A, D. This can be done in 3 ways, this can be done in 4 ways, this can be done in 1 way, or altogether the entire journey can be done in 12 ways. AD can be done in 3 ways, so 12 plus 3. This entire path can be covered in 15 ways. You are selecting 10 numbers randomly out of the first 100 odd numbers. Sum of these 10 numbers is A. How many different values of A are possible? Okay. First 100 odd numbers would mean 1 to 199. Okay. Now, when the question asks me how many different values of A are possible, I'm going with finding out the smallest limit and the highest limit. The smallest limit would be when I take the 10 smallest odd numbers, 1, 3, 1, 3, 5, 7, 9, how much? 11, 13, 15, 17, and 19. These are the first 10 natural numbers, the first 10 odd natural numbers. Okay. When I add them up, I will get a summation of middle term is 11. Sorry, this is not even the middle term. This year, middle term is 10 and number of terms is 10. It should be 100. Now, if you were to extend it to the extreme case possible, can you see it will turn to 199 and 197, blah, blah, blah. And here it would be 181. Everything basically gets added by 190. And the sum here would be 1900. Things that you need to be sure of or take care of are, if you're adding 10 odd natural numbers, if you're adding 10 odd numbers, the sum will of course be even. The smallest sum that you're getting is 100. Can you get to the next even number 102? Very much so. From 19 to, if you go from 19 to 21, the sum will turn to, because these 10 numbers are being taken out randomly. From 19 to 21, if you go, the sum will turn to 102. Can we go to 104? Yes, from 19 to 23, if you go, the sum will turn to 104. Basically, with repeated iterations, it is possible to see all even numbers from 100 to 1900 can be generated. All even numbers from 100 to 1900 can be generated. Even numbers. So instead of worrying about even numbers, let me worry about consecutive numbers. I divide this by 2 and I divide this by 2. So from 50 to 950, everything can be generated. From 50 to 950, everything can be generated. Of course, in order to get to the final result, you need to multiply it by 2. So from 50 to 950, how many numbers are there? If that I have to identify. See, from 1 to 950, I am, instead of counting 1 to 950, I'm only counting this much. So how many am I excluding from my count? I'm excluding 49 from my count. So the answer should be 950 minus 49 or 901. Answer to the question should be 901. Next question. There are 10 different fruits and 5 different vegetables. A grocer has to choose 3 fruits and 2 vegetables in all possible ways. He can do so. What is the number of selections in which a particular fruit or a particular vegetable are always there? Okay. So let's say 1 fruit and 1 vegetable is fixed. He needed 3 fruits. So now you'll select 2 more fruits out of the 9 remaining fruits. So 9C2. And he needs to select 1 more vegetable out of the 4 remaining fruits. That will be 4C1. 9C2 is 36. 4C1 is 4. This can be achieved in 144 ways. And that is all for this set. Hopefully you learned something.